want to do a demonstration of how I might simplify some code, mostly as a way of understanding it better. So this is some code that one of you wrote, and the one of you who wrote it will recognize it. And it's actually totally fine code. However, I found it a little bit hard to know exactly how it was working, which is pretty normal for a code that you didn't write, which is actually why it's really important to go to lengths to try and make code clear to people other than yourself. Because some things, there's just like, you know what things are for when you write it, and so even like a name that isn't that clear is clear to you because you know what it means. But if someone comes in and doesn't know what it means and the name doesn't give them a good clue, for instance, it can be hard to understand. Also, just when there's a lot of code altogether, it can be hard to understand. So this is not a ton of code, like 65 lines in total. It's divided into basically 3 functions, but each function is like 20 lines or so, 10, 15, 20 lines. Okay, so I'm going to show you how I might go about, at least to my light, simplifying this. So the first thing that I actually noticed when I was looking at this in the PR was these 3 variables up here do they all need to be global? And so the first thing I did is I looked for where they're used, and it took me a little bit longer than I'm going to take here, but like, so selected I actually figured out is used in this onClick, and I had looked at this code previously, so I knew that onClick actually does 2 things. One, if you click over here on these numbers, it's how you pick the number that you want to put in the board. So like if I click this 8 and then I click here, it puts an 8. And so that's like this first case of x is less than the edge size. It's basically over here somewhere and in this top row. Then we find which number we're pointing at and store it in this global variable selected. And then the other branch, when you click actually in the board, it uses selected. So that one is legit a global variable. IndieLen, I don't know quite what that stands for, but I do notice, and the editor will nicely show me when I highlight it, it's used in these 2 places. So it's actually only used within this function. So my first thought is just to take that and put it here. And there's also a pattern I noticed that it gets initialized to 0, it gets used in this loop, and then at the very end, actually of each iteration of whatever loop this is, this inner loop, it gets set back to 0. So that makes me think that actually this variable is really only being used inside this loop. So I can move the declaration there, and then I can get rid of this. So this is all just tiny little tidying. I'm just trying to like reduce the number of things I got to keep in mind. Index, I think, probably has a similar character that is only used in here. So I think for now I'll just grab that and move it here. And we can test, like, did I break anything if we click. So there's this thing has a, actually maybe that's fine. Like if once you select a thing, it's selected for a while. But anyway, that seems to work. So we're good. Now the other thing, there's this very complicated bit of code going on here. This whole thing, the board, which I assume what B stands for, was actually a little more than the board. So it's an array of 9 things, which is presumably like the rows, and then each row is filled with an array of 9 things, which is presumably the columns. But then each of those is itself an array that starts out a 1-item array with empty string as the value. So I'm not sure, I mean now I know, but looking at that initially I'm not quite sure what's going on. And so then I see in this, actually I'm going to go ahead and break one thing out first. Okay, so this code, right, we talked about how the onClick has these 2 branches. So it's really doing 2 different things. So I'm going to break out a function, get selected, and if we look at this expression, I'll just paste it here, but rather than setting selected, we're just going to return it. And this only depends on x and edge size, and edge size is kind of a global constant. So really this function just needs x as an argument, and it returns its value. So this is not a big change, but it just makes it a little, and we pass x. Okay, and then more to the point, we're going to take everything in here, and I'll start by just copying it. I'll put it down here, and I'm going to make a function. And what is this thing really doing? Well, it's placing, roughly speaking, it's figuring out the row and the column, and it's taking the selected value that we previously saved by clicking on one of the numbers in the palette, and then we're sticking it in the board, and then we're doing some other stuff, and we're drawing it, and then we're doing some other stuff that we'll get to in a little bit. But basically, this is placing the selected number, and it needs, at least given what I've copied here, it needs x and y, and maybe that's it. So I'll go down here, oops, close my function. All right, so we use the x and the y and the global constants of edge size and height and whatnot to extract the row and the column. I'm just going to swap those around because I always say row and column, so I'm going to do it in the order I say it, row and column. And then we take and select it as global, as we discussed. So we stick global in the 0th element of that thing that was originally a 1-element array. And then the next line does a kind of funny thing where it sets an index that doesn't actually exist yet in the array. That's actually fine in JavaScript. It will just like extend the array as needed. So basically, if we selected 8, it will add an 8th index slot to that array and put the value 8 in it. So what this seems to be doing is recording that 8 has been used in this row and column. And we'll get to in a second what that's all about. And then we draw the text. And then we do some other stuff here, which probably is a little puzzling. It certainly was to me. Now I understand it because I've looked at it for a while. Okay, so this should work. So we should be able to take all of this and replace it with place selected number x, y. And then we can try out. Does it still work? Oops, did I click 7 really? Yes, okay, still works. So again, not a huge change, but it does kind of just makes this a little bit easier to read in the sense that now it's like, okay, either in this case we get the selected number, or we place it. Cool. Then the other thing, we haven't really looked at line 9, and I'm going to move this thing down to the very bottom just because I like to have all the function definitions first, and then the anything that actually sort of runs, like drawing the board, etc. And I probably actually would move this down. So we draw the board, and then maybe we register our click handler. That's another, and then it's nice to have this be simpler because it's just going to be done here. So the bulk of the code is in these functions that we're writing. Okay, so the other thing I notice now is this chunk of code and kind of this chunk of code is very similar. It's got drawing the text, it's got setting the index, it's got this loop with this sort of funny double thing, and this other nested loop. So that cries out to me to be broken out into some functions. So the first thing I want to do, and I think when I was looking at this the first time, one thing I actually just, this line of code is pretty complicated. Just it's got a bunch of expressions in it. And I wanted to see, I wanted to actually thought, well, maybe I'll break that out as like draw a number. And then I pasted that one, and then I grabbed the other one that looked similar and pasted that. Format document, okay. And I'll just adjust the spacing to see that, okay, well, obviously these two variables were different. but they're presumably the same kind of thing. Col versus I. Let me just assume that I was also representing a column and J was also representing a row. And then the only real difference between these two is the color, right? So this variable, and let's say we made a function here, or sorry, if we made an argument to our function, which makes sense because we're saying draw some number. So we'll call this number, and we'll call this number. And these two lines are the same except for the color. So that actually suggests that we should pass the color as an argument. And then also this thing depends on a row and a column. And otherwise it's edge size and height, which are, so we replace the color with color, row and column were already there, number we just changed. So now we have two basically identical lines. And so obviously that is captures, and it just hides some of the complexity. So now we can come over here and instead of draw this whole thing, draw a number. What was it? This is selected, row, col, black. And we go down here, draw a number, index, I was row, J was column, and gray. Oh, sorry, J was column, J was column. J was row, I was column. There we go. All right, because this was I, that was column. Okay. And again, test, make sure I haven't broken anything. Oops, select something. Oh wait, did I break it? Dang it. Oh, select is not defined. Line 30. Sorry, selected. Okay. Okay, that seems to work. So again, none of this is like rocket science. I'm just moving code around a little bit. You might feel like, what's the point? Is it really that much easier to redraw a number? And I just think it is. Like, and mostly because when you see two calls to this function at line 28, highlight them, line 28 and line 54, we know that it only depends on the number you're drawing, the row and the column, and the color. And we don't have to work, like before when it was these two calls to draw text, you'd have to actually parse all of these expressions to see, is it doing the same thing? Because at one point I thought maybe the one that were being drawn in gray were like, maybe it was supposed to be this, like sometimes you have little small numbers in a Sudoku grid to show you like possible numbers or something. And so just, that was actually the question I had in mind, is like, are these really drawing the same thing? And they are, it's just one is gray and one is black. And I assume we'll get to why maybe that might be later on. Okay, so that's one thing. And then we have this, now we're getting down to the really slightly complex part of this, where, what is all this stuff doing? And without even worrying too much about what it's doing, I can say, actually the other thing I would do is I say, okay, all of this code except for the draw number is just like manipulating the board in some way, and then the draw number is actually drawing it. And there's nothing that matters, like nothing in this is actually changing anything but board. So it's safe to move this line down. And just as a tip, I'm hitting Command Enter to open a new line that's nicely indented like this. I think you can do that wherever you are, like in the middle of a line. So that's kind of handy. And Command Shift Enter opens a line above where you are, no matter where the cursor is. So those are some handy editor keyboard shortcuts. Okay, so I'm going to move that out, and then I'm going to look, can I do the same thing down here? Where I take this, and it's going to be in the loop after that. Get that indented right. Okay, so now I have even more similar code, and I could go even further like, as we kind of said before, like J is really row. So I'm going to rename that symbol to row everywhere. And then I am going to rename the symbol to col. And so now this code, these two sets of code are getting even more similar. This one has this line, the other one doesn't. Actually, turns out I think that's doesn't really matter because these loops are going to also set that same position. But down here, it's a little more confusing when this code is being run. But this code from here to here, or even really to here, is basically the same as this code. So that suggests to me that I should break it out. I'm going to actually leave the draw number separate. But I'm going to copy this. I'm going to make an empty function skeleton, paste it in, and I'm going to look at what variables do I need reference to. So I have selected again, row and column. However, I know that I just copied this where it used selected. Down here it uses index. I don't really know what the relation between those are, but I can see that it is always going to be one of these numbers. So I'm going to rename that to number. So then we need to figure out what foo actually is. So what is this doing? This is putting the number into the board at a given row and column in the 0th element of that sort of third level of arrays, the thing that started out empty. So that seems to be like the number that was actually placed. And then it also sticks the same number in at the index itself. So this is kind of using the fact that the numbers in Sudoku go from 1 to 9, and so we can use the 0th position as like the actual number that's in the square, and then we can use the indices from 1 to 9 to record the fact that that number was used or something. It turns out that's what's actually being recorded. So I think the idea here is, and we'll see actually when we examine this line 9 function, that what's going on is we're trying to record the fact that once we place, say, a 1 in some particular square, some row and column, that means that that number has been used in obviously that square, but also, and that's what these lines are doing, all the other squares that are in the same row and the same column, and then this thing is doing the same box. So now we kind of have to analyze this code and see that. So this is looping from 0 to 8, like 0 to 9 exclusive, and then but using the row that we're placing in. And so for every column of that row, we record that this number that we're placing has been used, and for every row in this column that we're in, we're recording this number has been used. And then down here, this is a little more complicated because of the trying to find the big box, but basically we're finding all the squares that are in the same box as whatever coordinate we're in, and then recording the same thing. Like when we place this 8, every square in this box had their 8th position of this array set to 8 to record the fact that 8 has already been played. None of these squares can use 8. So I think that's what's really going on, which also suggests that this is gratuitous because we're going to hit it like 3 times in all these loops. So we can go ahead and take that out. Okay, so this is like, I don't really know what this is doing. Place selected number. What is this? Record placement, maybe. So that was this code that I copied. And so now we replace that with record placement of this context. It was selected that we were replacing row, column. And that's all we need. Okay, so now this is starting to be a little bit, all right, we get the row and the column, we record the placement, and then we draw the selected number at that place. And I like, the reason I didn't include the draw number in this function is this makes this function more cohesive. All it's doing is what it says on the tin. It's recording the placement of that number, which includes recording the actual number in the 0th position and then recording in the related squares the fact that this number has been used in that line, in that column, in that box. Okay, so now, payoff time, down here we should be able to say record placement of index, which is what we're calling the number, also at row and column, and that should be all of that same code. And so we record the placement and then we draw it, but in gray this time for reasons. All right, so now we've actually made the code a little bit longer in terms of lines of code because I've introduced these functions. Also, I've introduced some gratuitous blank lines. But it doesn't always get shorter in lines of code, but it gets simpler in sort of number of things you have to take care of at one time. So let's see what else we can do. All right, so now now that I can see, okay, well, this is just recording a placement and drawing the number, but in gray. Now it's time for me to tackle, what is this code actually doing here in line 9? Like line 9 kind of hints at the name, kind of hints at what it maybe is doing. And we can definitely see this is doing something for every row and column. And again, I'm gonna, since we're doing it for every row and column, it doesn't matter what order we do it in, so I'm gonna do it the traditional row column. I just like to keep things parallel. All right, so for every row and column, we set this indilen, which I still don't know what that stands for, to 0, and index to 1. Then we loop over the C, looks like it's going from 1 to 9, right, not including the 10. So that's actually kind of like the number or the digit. So maybe I'll rename that digit. Or what I've been calling it number elsewhere. Let's just call it n, because I've been calling it number. And in this case, I would actually write it, since it's not really an index, I would write it like this. I don't know why. This makes it more clear to me that this is going from 1 to 9. And then this is checking if that number is already in that place, or sorry, not if it has been placed in one of these, like one of these, it's been recorded as it has already been used in some other square, or possibly this one, in the same row or the same column or the same box. And so it's also worth noting back here, like these could, in fact, probably will duplicate, like multiple of these will set the number in this, if it's in the same column and the same box, but that's fine because we just want to know, is it in this square, has it been used in one of the things that constrains it? And so then we increment indilen, and I'm going to put braces here, just because that's what I do. And then, so basically, if it is not available, right? If it's been recorded in this slot, then it's not available, and so we're basically saying indilen goes up. So the number that of digits or ends that aren't available to us in this particular row and column has gone up. So that I'm going to suggest maybe call it unavailable. So it's unavailable starts out at 0. They're all available, and then each one we see, we increment unavailable. If it is available, then we hold on to it. And so index is kind of, again, a weird name. I would probably call this like possible. This is a possible number. And we're not actually keeping track of all the possible numbers. We're just, every time we see one that is possible, it stomps the old one. But that doesn't really matter, because now if we look down here at this if, it becomes a little more clear. If unavailable equals 8, meaning all but one of the digits are unavailable, then that means there's only one digit available. Therefore, the last thing that we recorded in possible is the digit that can go in this square, assuming that this square is empty to start with. in which case we record that and mark it gray. So now we can see what's happening is we're recording the digit without the player having to have played it. So we're coloring it gray because they didn't really do it themselves. But it's like if once there's only one possibility for a square in like a line or a column or a box, it gets filled in automatically. So it's like a partial solver. It doesn't like solve the whole puzzle, but it does the trivial thing for you. Okay. And this now confirms that like these variables, which were originally globals under a different name, actually we need them inside for each row and column. We need a new set, and then we start again for each row and column. The other thing, so then there's some other things I might do here is like, well, this whole thing, like this only matters if the square is empty to start with. So I might actually copy that and then move that up here and say for the row and column that we're on, if it's empty, do something. Otherwise, don't bother even checking all this stuff. So then we can take that out of here. And let's see, make sure I haven't broken anything. Loaded. Actually, does this? Oh, I don't think this function ever gets called yet, so it's not going to do anything. Okay, and then I would, yeah. So this is fine. I would maybe even go a little more direct. Well, like we talked about how we don't record all the possibilities, but I would say maybe something like this. Make an array, which then means we can make a const. Make an array of the possible values, and then we don't have to count the unavailable. We just have to collect the possible ones. So when it's not forbidden, it's possible. And then here, if possible length is 1, if there's only one possibility, then we stick that one in. Logically, not all that different, but what it does do is it lets me now take this code, break out a function that I wanted to take this too. Makes a list. So there's just like all the accumulation functions on various assessments where we push the things we want and then we return it at the end. And now we can say possible equals possible digits. And then we check, does possible digits need any arguments? No, n is a loop variable. Oh, it needs row and column. Row and column, row and column. So now this is getting kind of simpler where we say if the row and column are not empty, sorry, if they are empty, that row and column is empty, we get the possible digits for that row and column. If there's only one possible digit, we place it. So now this function, line 9, is maybe fill last possibility. And this function is certainly quite a bit simpler than where it started, mostly because we've moved a lot of the GORP out into other functions, but those functions are also easier to digest. Like this possible digits, which contains a good chunk of the lines of code from before, we stripped it down a little bit by not getting rid of some of those other extra variables, but it's a very simple pattern that you should all be familiar with now, where it's make a list, make a collection of things that meet some criteria, and return the list. So this is like easy to digest, and some of you will know how to maybe even write this as like a one-liner using array functions and whatnot. But even as this is perfectly digestible. We can also, it tells us what it does. We can collapse it and be like, all right, we don't have to worry about how that works. And so now I'm going to put some just headers in here. This is all right. Just little header graphics, drawing and translating graphical coordinates. So that's this section of code. That actually raises an idea for me that place selected number is currently written in terms of graphics coordinates, but mostly it's and I guess draw number translates back into graphical coordinates. So there's part of me that wants to change this around. So let me do this first. First, I'm going to copy this. I'm going to paste those. I'm going to use a little trick that I think we talked about with some of you once at the whiteboard, but I haven't ever taught. But I'm going to show you right now. Okay, so I'm going to make a function row and column that's going to take x and y and going to translate to an array of the row value and the column value. So that returns a two-item array of the row and the column. And then we can come over here and do what's called destructuring. So this is a way of basically declaring the row and column variables at the same time as we take apart the array. So the first item of the array goes into the row variable and the second item goes into the column. And let's just check that that still works. Yep. Okay. And then I would go even a step further and say, let me find the place I call place selected number, which was down here. And let me just do that here. And instead of passing the xy into place selected number, I'm going to pass the row and the column. So I'll translate them first and then let this guy be written in terms of row and column. And so that kind of separates it from the graphics stuff. And now state management. So it should be everything below this line 28 should no longer be in terms of x and y. It should be purely in terms of rows and columns. And so that kind of divides this program. This has to do with the specific graphical coordinates that we're using in this environment. This has to do with the sort of logic of Sudoku independent of the graphics. And if we were using some different UI or we wanted to have a text-based one, we could still use this code and would not use this code. So it's good to disentangle things. All right. And I think that's pretty good. And I think actually now we're at the point, and we probably were at the point at the very beginning where this function, which used to be called line 9, we could just call, I think. See what happens. So now if I do 1, 2, 3, 4, 5, 6, 7. Moment of truth. Ah, look at that. It works. Okay. So I will point out that I don't believe I added any functionality to this code in the course of this editing. All I did was move the furniture around in a way that I think is maybe a little easier to read. It might seem, I know that newer programmers tend to write longer functions, and in some ways maybe it feels easier to have just like one thing that you have to look at, but you should really get used to like writing small functions that you can sort of Look at this. We know what it does. Given a row and a column, it returns the possible digits. Done. Fold that up mentally. You don't have to worry about how it works. And now you can understand this code as, okay, we get a list of possible digits. Great. And then if that list is one long, then we can do stuff with it. And it's, so you get to like hide details, which is what abstraction is all about, and make it easier to understand each piece of the functionality. And then you just have to see how they fit together. So now this register click is like, doing a little bit of the X and Y. I could technically break those out into functions too. But so if we're on the edge, we get a selected thing. There was one last thing I wanted to do here. Record placement. Oh, I guess I did that. Place selected number, record placement. Oh, I see. Place selected number. Okay, yeah. So actually, right, there's two last bits of place selected number, records the placement, and then draws it. And we use that down here. Oh, and then that. Whereas here we call record placement and draw number. So there's like these two lines and these two lines are basically the same. The only difference is the selected and the color. So we could, one last step here, add a parameter number and use that instead of selected. So this records it and draws it. And then over here we now have to pass in selected. And then that means here we can say place selected number possible 0 row call. Oh, and then the color needs to differ, so we'll add that as an argument. And that means we need to add it down here. All right. And so now these two lines are no longer needed. So if possible length is 1, place the selected number of the only possibility there is. But draw it gray. So let's expand this again. All right, so we've got draw board first, which I just can't help but rename things. Since there's no draw board second, I'm just going to call that draw board. A thing to draw the board. We have a thing to draw a number in a given color at a given row and column, which translates back to graphical coordinates for us. We have a thing to translate an x coordinate into get selected. We have a translate from x and y to row and column. So that's all, everything doing more or less, except for down here, to do with x and y. Then we have our board state management that I guess technically also does call back into the graphical stuff. But we place a selected number. This just does the actual board state management. This does our automatic filling in a reasonably, hopefully, clear way now. For every row and column we check and do it. Possible digits is a little helper function, and this is all very reasonable to me. Probably my last rename would be to call this board, just on the theory that global, the larger the scope of a variable, so this variable exists everywhere in this function, should have more verbose names, and local variables like loop variables that are very constrained, their scope is only the body of the loop. It's okay to have very short names, particularly conventional names like I. But so I would be more happy with like row and call. Well, row is a full note word, but call is short for column. But that's okay because it's just a parameter to this function. But board is global, so I make it fully spelled out. All right, so that I think does everything. And I'll point out, sorry, everything, but one last thing I'll point out now is this function is actually quite useful in that it records, does all the state management and draws, and can draw in a particular color, which suggests we could actually set up a puzzle. So let's make, I'm not going to get a real Sudoku, but like, I'm just going to make a puzzle, const draw puzzle, just because I like to put things in functions. This is just going to do some random stuff. And so it's going to do like place selected number 1, and we're going to put it in 3, 4, and we're going to draw it blue. And let me just make sure this works. So then after we draw board, we're going to draw puzzle. And so now we have a Sudoku with 1 given. And that actually brings up place selected number. This isn't placing a selected number. This is placing a number we just gave it, which is also true in fill last possibility. So that suggests that this name is wrong. And really, this is just place number. So this is another thing it's good to pay attention to. Like when you name a function, initially it might have some meaning, but then as you combine and realize you can use that same function from other places, the name no longer actually is quite accurate. And it's I would say important to go back and change it, especially in this editor where it's so easy to rename things. Just rename the symbol to what it actually is, and now, it's a good, and then check. Does place number, is that accurate? Yes, this is definitely placing a number. Is it here, place number 1? Is that accurate? Yes. And down here, also accurate. It just happens to be that the number is selected, the selected number. So obviously you can see how here, like more givens, you could put in, hardwire a particular puzzle, or you could find some way to represent the givens of a puzzle as an array of coordinates, or whatever, a bunch of things you could do there. So I want to thank the student whose code I used for this demonstration. I want to point out that this code, I didn't add any functionality to this code. I don't think I fixed any bugs in this code. So everything that is here now was actually here at the beginning. It took me some puzzling to figure out, and basically took me doing this to it to understand what it was doing for myself, which is not to say that it was not understandable to the author of the code, but I think this would be more legible to someone who was coming to it cold. So anyway, that's the end of that demo, and hopefully this all got recorded and you have enjoyed watching it. Thanks a lot.